In lecture number 31, 32, 33, we will be looking at the topic of arrays, that's ARRAY, and it's the simplest data structure, it's a sequence of objects which all have the same type. For example, I've declared an array of name A, and it is a size of 3. That means it can store 3 double type values, and the index of array in C language or C++ language goes from 0 to whatever the size -1. So if I have 3 element array, the index or the subscript of the array will go from 0 to 1 to 2. So, or let's say if I've declared an array of size 5, the index number will go from 0 to 4. The telltale sign about arrays is that we are going to use the square brackets. For example, if you are calling a function, obviously you're going to use some kind of round brackets. If you're writing some kind of a code block, you're going to write the curly brackets. For arrays, the most important sign is that we are going to use the square brackets, and these square brackets, they are used to declare the size of an array. Just like we have declared an array of name A of size 3, that means it can store 3 elements. It's a simple data structure, and each object or each element in this array is of type double. So if I have declared an array, for example, if I write integer b and I write 5, that means that I've declared an array of name b, and it can store 5 integers. So the memory in this memory space, even though I am drawing it vertically, but in actual memory space the memory is allocated in this fashion. But usually what we have seen here is that people understand it better if you draw it vertically for some reason. Okay, so this memory structure, the name of this memory structure is b, and the first index is 0, the second the index is 1, the third index is 2, and the fourth index is 3, and the fifth index is 4. So let's say I've declared just declared it, and that means that each integer is of 4 bytes. So the computer or the compiler has now allocated 20 bytes of storage for this array b. The name of this array is b, and if I want to access the first element, I'm going to write b0 in square brackets, and if I want to assign a value, because here it will just contain garbage values, because only the memory space has now been allocated, but we haven't initialized any value. So if I want to access the first value, if I want to initialize the first value, I'm going to write, for example, b0 equals to 4. So 4 will be assigned to the first element in the array. And let's say I want to access b4, so and b4 equals to 7. So this fifth space or the fifth memory location will have the value 7, and if I write b3 equals to 9, so b3 will now have the value of 9. If I write b2, if I just going to assign the values, obviously, so these are just simple statements. So b2 contains the value, for example, 10, and this will contain the value 10. And if I write b1 equals to 0, so the b1 this second location will contain the value 0. So we have 20 bytes of storage allocated to this data structure known as array, and this array is essentially a sequence. Array is essentially a sequence of objects which all have the same type, so all of these are integers. So actually in the memory, the first location will have 0, the second location will have 0, first location will have 4, second one has 0, third one has 10, and fourth one has 9, and the fifth one has 7. The important thing is the size of the array. The size of the array is 5 elements, and the size in bytes is whatever. If you have a 5 element array and each element is of type integer, so obviously it's of 4 bytes, so the whole size of this array is going to be 20 bytes. So if I've declared this array as type double, and if I've written, for example, double, and if I've written double, for example, d, and if I write 5 here, and we know that the double type floating point numbers each occupy the memory space of 8 bytes. So that array of name d will be of 40 bytes. That's 40, because each element, because I have like 1 2 3 4 5 elements space here. Each space is of 8 bytes, so that would be a 40 byte data structure, and each location in this array can hold a double type value. Coming back to this, we have declared an array, and it is of size 3 element array. The index number will go from 0 to 3 minus 1, 0, 1, 2. So counting always starts from 0. If you are doing MATLAB, the counting starts at 1, but in C or C++ it is we are talking about the zero based indexing. So it guarantees that the index of each array element is equal to the number of steps from the initial element A0 to that element. For example, A2 is 2 steps away from element A0. So if you want to assign the value, you would assign the value to each element, just like you would assign the value to just a normal variable. And and if you want to access that element, you would just write A0, A1, A2, or whatever, just like you would write the name of any variable. But the benefit of using arrays is that each memory location is of same type. As in this case is double, and it's using numbers as subscript or the index number, so obviously we can use the loops. So if I'm going to first run this code here, and it says A0, A1, A2, I mean this is just a string, you can just write anything here, 11.11, 23.33, 55.55, whatever. I mean we can access it directly to any element in the array. I mean it's not necessary we have to access it sequentially. We can just access it in any order if you want to, but if you want to access it sequentially, you can use the loops here. So because loops go from the counter of the loops go from 0, 1, 2, 3, 4, 5. Similarly, the array index also move in the same fashion. So if you want to initialize an array, in this case we have declared an array, but we haven't written the size here, but here we are giving 3 elements. So this array size would be 3 size, I mean 3 element array, and the actual size in bytes would be let's say the float is occupying 4 bytes, so this A is going to occupy 12 bytes of memory, and it has 3 locations, and first location will contain 22.2, the second one contains 44.4, and the third one contains 66.6. So if I want to have the size of the array, because each compiler, depending on what computer you're using, sometimes the float might not be a 4 bytes, so we don't know really. So if we write size of A divided by size of float, this is a function, this is a built-in function of C++. So size of A divided by size of float, so size of A would be 12 divided by size of float, that would be 4. So that will go from the size variable will contain 3, so that will go from 0, 1, 2. So I'm going to, and the index will go from 0, 1, 2, and once it gets to 3, the loop will exit. So it will just print, even though I do not need to do that, I mean I could have just written it 3 here just by looking at it, but sometimes the compiler might have different size allocations for different variables. It depends on computer. So if you run this code, it's going to say A0 22.2 and 44.4 and 66.6. So if you want to initialize an array, you have to use the curly brackets. So let's do this example. Here we are taking the constant integer, you just write size equals to 5. I mean the array size has to be known at the time of its declaration. So it's important that either you take the input from the user or you just write it yourself. You might want to make it a constant so that it's not overwritten later. It depends really. So it's going to print the arrays in reverse order. We are going to take the input from the user, and it's going to print those values in reverse order. So if I run this code, let's see. Enter 5 numbers. So if I write 22 and 11, 55, 66 and 77, so in reverse order it says that the last one was 77, because I'm running this code, I'm running this loop actually from the maximum. The size is 5, so the maximum index would be 4 to all the way to 0, and I'm in each iteration I'm going from 4, 3, 2, 1, 0. in this if I want to initialize an array with trailing zeros, so I can do that. So here I have written the size of the array as 7 elements, but I've only initialized it with just 3 elements. So this one would be at A0, this one would be A1, this one would be at A2. So if I run this code and I'm going to print that, the rest of the elements are initialized to 0. So we haven't left them uninitialized, so they, even though you have written or if you give lesser quantity of values, the rest of the values are initialized to 0. Here there's an error that I've written the size as 3 and I have written 4 values, so obviously there's too many values. So if I've written like that, or this, exactly they mean the same thing. So even if I've just initialized with just one value here, or maybe 2 values, the rest of the values are going to be 0. Or I could just written all the values as 0. It depends if you want to initialize an array. It's a good practice to actually initialize an array. Do not leave them uninitialized because they might contain some garbage value. So if you are talking about the garbage values, so if I declared an array but I did not initialize it to any value, I mean even if I've just initialized just one value with 0, all of them would have been 0, but here I haven't initialized the array, that would probably print some kind of garbage values because it has allocated 4 into 4, 16 bytes of memory in the memory space allocated by the compiler, and that memory space might have been used by some other process, and that process would have written some other garbage values for us. So this program is just reading those locations, and that's it. So if I write, for example, I'm going to explain that in lecture number 31, 32, 33, 34 when we do the pointers. So if I write cout and if I write just a, what do I get? So if I'm not dealing it with this array, there is an hexadecimal number. This is actually a memory address. So what I'm going to do is, this memory address, since I'm using a 64-bit computer, each memory address is of 8 bytes, so it's not displaying the leading zeros here, because I can write 100 or I can write 00100, so it means exactly the same thing. So it's actually displaying some kind of a memory address. So the important thing to remember is that the array name is actually a pointer. Array name is actually a memory address. So if I write an L here, and if I write cout a plus 1, so obviously I'm going to get the next memory address. So this is because the type of a is actually float. Okay, so for A0 is actually the first memory address, which is actually a here, a plus 0 or a, and that's this memory address. So if I write a plus 1, since I know the type of this array, which is float, that means each element is of type float, the next memory location would be 4 bytes away, so that will contain this value. The third memory location would be obviously 22 FE28, and that will contain this garbage value. So just to emphasize this thing, I'm going to copy this code and I'm going to write a plus 2. So if I run this code, obviously it's going to display the third memory location of 28. So it's jumping 4 bytes because I've declared the type of this array as float, and we know that float is of 4 bytes. So each memory location is 4 bytes away from the previous memory location, but since we haven't initialized it, so it contains a garbage value, might have written by some other program process. One last thing in this thing is that if I declared, somebody has asked in the live lecture, I think I might have answered it incorrectly. I haven't initialized it, it's an empty array. The size in this compiler is actually 0. So let's see, size of a, even though it should display some size, but it's actually displaying 0. I'm not so sure why, but here if I've declared it, for example 1.0, that's the first element, so it's a single element array. Now it says the size is going to be 4. So your results might vary depending on what compiler you're using, what IDE you're using. So this thing is using TDM-GCC compiler. So you might have a different compiler, so it might be displaying some different results. Okay, so I think we have done these files. So what happens that we exceed the array index. C++ or C language does not have any built-in safety features. If you exceed the array index, it will just keep on going, because we know that array name is a pointer and it's just an address. So we say that size equals to 4. Okay, I mean, you do not need to, if you are not happy with this line, just don't write it, just write A4 here if you want to. Okay, so the size is 4. We have initialized to 4 elements. The first element is A0, the second one is A1, A2, and this one is A3. But we are going from I0 to I6, so that will go from A0, 1, 2, 3. That is okay. So A3 is 66.6. Then it will go beyond 3. It will go to 4, 5, and 6. So this is index is out of bounds. It's not an error. It's actually a runtime error, but it's not going to throw up an error, because we are just saying look, we are just saying that the first value is 33.3, the next one is 44.4, and the next one is 55.5, and the last one is 66.6, which were our legal values. But here A4, A5, A6, compiler does not throw up any problem. The program doesn't throw up any problem. This is actually a runtime error. We have to keep in mind that we should not exceed the bounds of an array. They always go from 0 to size -1. So if you are exceeding that, that might create some problem here. For example, if I write this thing, this array, the index goes from 0, 1, 2, and the size of the array is going to be obviously 3 here. So I haven't written the size. It's going to pick up the size here. Actually, sorry, the size is 4. Why I have written that? Actually, it's not necessary. I'm not even using that. So let's remark that the size is going to be 3 here. So the valid index goes from 0, 1, and 2. Okay, now what I'm going to do is that x equals to 11.11, some random value, and I'm going to cout x, and I'm going to assign the value 88.8 to this location, even though I do not have the legal right to access this location, because this is way out of bounds of my program. So it's probably going to crash this program. Let's see what we get. Almost guaranteed crash. Xzeta has stopped working because I am accessing the memory location which is not which should not be accessible by this program. 1 or 2 memory locations might work, but they are actually in error. So this is not a good practice. So let's take a look here. We have to keep in mind whatever array index is, we have to keep within those bounds. Okay, so if I write I mean, this line is not even used here, so probably just a copy paste from some previous program. If I write double A equals 22.2, 44.4, 66.6, that means that I have double is of size 8 bytes, right? So we have 3 locations. Let's draw that. So we have let's draw it somewhere over here. So we have 3 locations, type double, 1, 2, 3, and each location is of 8 bytes. So it's actually, this whole array is going to be of 24 bytes. Now what we are going to do, we assign 22.4, 44.6, and 44 and 66.6 to these locations. So we are going to 22.2, 44.4, and 66.6 to A0, A1, and A2. Sorry for bad writing. Okay, so coming back to here, now what we have done is we are writing float x equals to 11.11. So what would have happened is that since let's hope, I mean, it's not necessary that you get the same result in your own computer. I have declared another variable x equals to 11.11. So in the next location, I mean in the computer memory, the first location is of 8 bytes, the second location is of 8 bytes, and the third location is of 8 bytes. Now this fourth location would be of 4 bytes, 8 bytes, 8 bytes, and 8 bytes, and this contains a value of x, and we have declared the value of x equals to 11.11. Now what we are doing, which is actually a disaster, is I'm allocating a value a3 equals to 88.8 because we know that C++ or C language does not have any built-in checks that you are exceeding your legal limit of array index. So I am assigning a3 equals to 88.8. So what it's going to do is, we know that a is the address of the first location. So a3, that is a0, that is a1, that is a2, and this thing is a3. I'm going to override this value with some garbage value, but they have some kind of a size mismatch here. So I'm going to write 88.8. so it's going to write 88.8, and it already had the value of 11.1. This was a 4-byte number. This thing is going to be an 8-byte number, so they have a different way to represent the floating point numbers. Let's see what we get. So we are going to see the value of x. So if you run this code, the value of x is 11.1. Then we wrote 88.8, so it just corrupted the value of x. So do not do that, because this thing is the side effect if you're going out of bounds for arrays. Returning to the example of the uninitialized array, we declared an array of size 4, so the index will go from 0 to 1 to 3, and we printed the values, and obviously it printed the garbage values. So the first cout statement in this line printed the garbage values. I mean, we allocated the array of 16 bytes because the size is 4 and the type is float, and it allocated an area or the space of 16 bytes in the memory. And later what I did is printing the value of a, and this is important that I'm going to repeat that the name of an array is actually a pointer. Pointer is a special type of a variable which contains the address in the memory space of the computer. And since I'm using a 64-bit computer, that means that each pointer or each address in memory is of 64 bits or 8 bytes. So if I print cout a, and if I print cout a plus 1, if I print cout a plus 2, and just for completion's sake, let's print cout a plus 3 as well, is going to print the memory address of this first location a. Actually the array a, which we have declared has type float, they contain the garbage values actually, but the address of that first location, that's the name of the array, or a is a symbol which contains the address of the very first location of this array, is this number, this hexadecimal number. So if we are saying 1 2 3 4 5 6 numbers, 0x means we are talking hexadecimal numbers. They should be 8, but actually it's 0022 FE20, and the next location a plus 1 is plus 4. So we moved by 4 bytes because the floating point number is of 4 bytes. So the next location has to be 4 bytes away from this location. So this then the third location is 28, and the fourth location is obviously 2C. So it's 28, 29, 28, 2B, and 2C. Now if I want to see what is actually stored in these locations, obviously these numbers are stored in this location. So there's some garbage value 1.4013 e to the power whatever 0, and then this number. They might have been written by some previous program. So what I'm going to do is, since the name of the array is a pointer, that's important, the name of an array is a pointer. So a is a pointer, which is a special type of a variable which can store an 8-bit number or 8-bit address. Sorry, 8-byte address, not 8-bit. It can store a 64-bit number or 64-bit address or an 8-byte address. So if I want to see what is actually printed, so what is actually stored in this location, so I'm going to write a. So I'm going to use the steric operator here. So I'm going to write star, and I'm going to write a plus 1 here. So here this is actually a dereferencing operator. So if you have seen the previous videos, I've used the ampersand sign, that is actually a reference operator, and here I'm going to use the dereference operator, which is the steric sign. This is not multiplication, this is actually seeing what is stored at this address using the star operator or the dereferencing operator. So I'm going to write a plus 3 here, and it's going to instead of displaying the memory, it's actually going to memory locations is or the memory addresses, is actually going to display what is actually stored on those memory locations. So I'm going to revisit this dereferencing operator. Let me write it down. So this thing, the ampersand is the referencing operator, and the star is the dereferencing operator. So if you're talking about the addresses, because the name of the array is itself an address, so we do not need to write the ampersand sign, but if we want to take a look at what is actually stored at that memory location, we have to use the dereferencing operator. So I'm going to revisit this star and this ampersand operator in the next next lecture, or the next lecture video of I think 34, 35, 36, in which we will do the topics of pointers. So that's well, if you want to take a look at what is actually, so I can actually access and change the values there using the dereferencing operator if I want to. So but this is an initialize error, so it contains garbage values anyway. So let's go moving to the next program. Here we are passing an array to a function. So actually we do not pass the whole array, because array might contain like thousands of elements, so it's actually very inefficient to pass the array to a function. So what we never do that. What we actually do is that we pass the name of the array to the function, or the address of an array to the function, so that the function knows in which memory location the array is actually stored, and it can work there and then. So here that is the function prototype. I could have written like because if you are declaring an array, you need a type here, and type is integer, and you need a name, and you need the square brackets. You do not need the size. The compiler doesn't really need to know what size of an array is. But I mean, that's pretty much the only two things we need to declare an array. So if I write this thing integer, or I could write integer a, or and if I write integer n, so it's not needed to name put the names in the function prototype, but it's actually important to write the names of the function prototype in the function definition. Sorry, write the names of the arguments. Sorry about it. We need to write the names of the functions, parameters of function arguments in the function definition, not needed in the function prototype, which we write in the very beginning. If you want to write, it's up to you. Okay, so let's move on to the main function. The main function, we have initialized an array. This is a size 3. The first element is a0, the next one is a1, this is a2, and this is a3. So size has to be 4, and the valid index will go from 0 to 3. So we figured out the size divided by size of a divided by size of integer, that is 4. So it's going to divide the total size of this array is going to be, obviously each integer is of 4 bytes, so 16 divided by 4 here, so that will be 4. So that will figure out that I am going to pass, look, what I'm going to do is I'm going to pass the name of an array and the value 4 here to this function sum. So it's going to take the value of a is an address here, a is an address, a is assigned to this name here, and this is actually passing this is exactly similar to passing by reference instead of passing by value, because we are passing the actual address of an array here. So I mean, I could have declared a pointer here and worked there, but since we haven't done the pointer topic yet, so we are going to use this method. So this a is assigned to this a here, so a is the name of an array, and we know that the name of an array is actually a pointer. So the function has the address of the very first location of an array, and we have passed size contains a value 4 here. Size contains the value 4 here, so we the 4 assigned to n. So the for loop, this for loop is going to run, and is going to run from 0 to 1 to 3, and it's going to end at 4. So here we have 0, 1, 2, 3, and the sum is 0, and in each iteration it's going to add up all the values of this all the values of this array. So in the first iteration the sum is 0, the second iteration is going to add initially this value of sum is 0, so it's going to add 11 to 0, then it's going to add 33, so the sum is going to be updated to 44, then it's going to add 55, so it's going to be 99, and then it's going to add 77, so I think it's going to be 176, and this value of sum, and then it's going to return the value of sum to wherever this function is called. So wherever this function is called, so it's going to return the value of sum. This is just a variable. We can have the name of the function, as well as we can have a local variable, just a local variable. So whenever this function is called, it's going to return the value of sum. So it's going to be probably 176. So let's run this code, and it's going to say that sum a size, which is here, equals to 176. So if you are passing an array, you are not actually passing the whole array, you are sending the address or the name of an array. So because it's actually virtually inefficient to pass like 1000 element array, we never do that. We actually just pass the first address of the array and expect the functions to work with the address, and we need to and the functions have no way of knowing that where the array ends. So we also need to send the size of the array, so that a function knows that if it's running some loop to where that array actually ends. Function has no way of knowing that. In this example, we are doing the same topic of passing array to the function, which is actually passing the address or the first location of the array to the function. We did never pass the whole array to the function. So we have two functions, one is read, another one is print. So in the main function, we are calling these read and print functions, and we have declared an array a of size 100 here. So if you do not want to run this line, you can just comment it and write 100 here. And I've initialized this array to all zeros. So it's going to be I'm going to call the read function, and I've also declared a variable size, and this size is passed here by reference. So this size variable is going to be we are actually passing the address of the size variable. So this size variable, even though it belongs to the main function, but the read function is going to can actually modify this size variable. So this read function, and I'm going to say cout this array has so many elements, so the size is going to be updated by the read function because I'm passing by reference here, and then I'm going to print whatever the values are of a as well as the size, because I need to, because the functions have no way of knowing that how long the array goes, or what is the size of an array, or how many elements the array has. The functions only because if I pass the first address, the function only knows that the type of is integer, so each location is of 4 bytes, so it's going to jump 4 bytes as it moves along each element of the array, but it has no way of knowing when to stop. So I need to send the size, whatever that might be. So let's take a look at size, and let's take a look at the read function. So I'm calling the read function, I'm passing the first address of the array, because we know that array name is a pointer. We have to remember array का नाम pointer होता है, don't forget that array's name is a pointer. So it's a pointer is a special type of variable which can store the address in memory. So if I am using a 64-bit computer, so each pointer or each address is going to be of 64 bits or 8 bytes. So even if I have a pointer to some kind of a character is of 1 byte, but the address of that character is going to be of 8 bytes, so don't forget that. Okay, so read function is going to take in the address of an array, and it's going to take the it's going to create the synonym or the alias for the size, because I'm passing by reference here. So it's going to create a synonym or alias. So it's going to change the value of n, and behind the scene that will be changing the value of size. So it's going to say cout enter integers and terminate with 0. So any positive or negative integers that are okay, but if I press 0, so it's going to not count that, and it's going to terminate the whole function. So this is n equals to 0 because I haven't entered any numbers yet, and it's going to run the do while loop cout, and the first a0 is cn, and take the first input, then c and c1 and c2 and c3, and it's going to a n plus plus. That means that a 0, a1, a2, a3 is not equal to 0, and n is less than 100. The size was obviously 100 here, so we do not want to exceed that. And after, if I press 0, so it's going to do n plus plus as well. So the size of the array might be of, if I press like 5 valid positive or negative numbers and the 6th number is 0, so it's going to increment n. So after that it's going to decrement n, so it's never going to count the 0. If it's counted 0, it's going to correct that. And then the print function just takes the name of an array, And the n is, remember that n is the size here, so size is actually modified by the read function because we have passed the value by reference. So print function is going to take the size and is going to run up till n, so 0 to obviously size minus 1, so it's going to run less than n, so it's going to just see out whatever elements we have entered. So let's running this code, and it's going to say enter numbers terminate with 0. So the first element, let's say, is 12, and then it's 15, and then it's 9, and this is minus 2, and then let's say it's 5, and then let's say it's 0. So even though I have entered 1 2 3 4 5 6 seventh element is 0, so it's not going to count that. So it's going to say that, sorry, 6 elements, 0 1 2 3 4 5. So I've pressed like 6 elements, but it's going to say it has 5 elements due to this minus n, and the elements are, it's called the print function, and this print function prints 12 5 9 minus 2 and 5 for the elements of the array. And since we have, these are actually single dimension arrays or one dimension arrays, we could also have a two-dimensional arrays. Two-dimensional array, they have rows. The first one is rows and the second one is column. So if you are running, if you're talking about a single dimensional array, the single dimensional array has single for loop or single while loops. Okay, so if you're talking about two-dimensional arrays, so you need two nested for loops. So if you're talking about 3D arrays, so you are going to talk about the 3 nested for loops. The processing a d-dimension array is done with d for loops, one for each dimension. Multi-dimensional arrays are useful for linear algebra. If linear algebra is done in your linear algebra and differential equations, or maybe analytical geometry, not so sure in which course you do that, but it's an important topic. Because you can have as many dimensions if you want, because we can only visualize like 3 dimensions. By 4 dimensions we cannot draw those 4th dimension or maybe 5th dimension, but computers can actually deal with that. So let's say if I want to populate this number at this location, so 25th, that is actually 26th row, 9th column, and 4th depth, if you want to call that, has the value of this. Coming back to 2D arrays, so I've initialized the 2D array. I could have initialized it like this in this line. So this is the first row, and column 0, column 1, column 2, column 3, and this is the second row. So that is a the size is 2 actually, so the index will go from 0 to 1. So this is like 0th row, and this is like 1th row. So it has a first column, second column, third column, fourth column. So the coordinates of this 2 here is going to be A1 A13. So coordinates of this 2 here are going to be A1 and 3, because the size, the maximum index goes to size minus 1. I could have also initialized the array like this, because in computer, I could have just written in this line, and that computer would have done exactly the same thing as with the previous line, because the computer or the compiler allocates the locations in array contiguously actually. So the first location, that's the 0 0 0 1 0 2 and 0 3. So this is 1 0 1 1 1 2 and 1 3. I'm talking about the coordinates like here. If I'm going to print those, so I'm going to row is 0, row is less than 2, the size is less than 2, so row will go from 0 to 1, and the column will go from 0 to 3. So for each iteration of row, the column is going to go from 0 to 3. So I'm just going to print the values of a row for column, going to put the coordinates from these for loops, and if I print that, the first iteration of this for loop, the row is value of 0, then it enters this for loop. So column will go from 0 1 2 3, so it's 0 and 0 1 0 2 0 3, so it's printing 5 0 2 3. Then in the next iteration, row, the value of row is 1, and the column will again go from 0 to 4, so it will be printing a1 0 a1 1 a1 2 a1 3. So the values are 0 0 9 2. In 3D arrays, exactly the same thing. You can just have rows, columns, and depth if you want to call that, so it's up to you. but it's actually quite hard to do that. But if you are doing linear algebra, so it's actually much simple to use multi-dimensional arrays that make the solving the linear algebra problems much more simple. They could have initialized because the computer really doesn't care that what you call rows, columns, or heights, or depths, or whatever. The computer is going to allocate the space to these numbers in a continuous fashion. So I could have done exact like this in this one single line. I could have done that instead of using the first row and first row column like 0, column 1, and then each column has the 3 depths. So this is actually one column, this is the next column, this is the third column, this is the fourth column. So if I'm going to the next row, so this is the first column, it has 3 depths. So you can, if you want to imagine, you can use to visualize this thing, you can use something known as a Rubik's cube. I hope you might have played that games, but the picture looks really similar to Rubik's cube for a 3-dimensional array. Last thing I need to specify here, sorry, the second last thing, I think I've already done that. So if you are processing this array, you need 3 nested for loops. Okay, so coming to here, this is dealing with 2-dimensional arrays. So I'm going to read A and then print A, and the important thing is that if you are passing the array to a function, so obviously you're not going to pass all the values because they might contain like too many values, so never going to do that. It's going to pass the I'm going to pass the name of an array. The important thing is that the next dimension has to be passed. The first dimension is not needed to be passed, but the compiler needs to know that when is the next dimension is going to happen. So we need to pass the next dimension whenever we are passing the arrays here. So I'm using a constant reference here. If you do not want to do that, so we are not going to cover that in our course. So if you not want to do that, so you can just delete this constant reference. So just to make it a read-only thing, it could not have modified that if I'm using a constant reference. That's a topic which we did not do in our passing by reference topic. So if you want to just pass the address and you do not want the function to modify the value, so you might want to use a constant reference here. I'm not going to use that. So it's going to say enter 15 integers, 5 per row here, and then it's going to run the for loop, and then then it's going to run another for loop for the column here, because I'm talking about a 2-dimensional array, so I need to have 15 values, 503, 15. The index will go from 0, 0 to 2, 4, because I'm counting from 0. And the print is also going to run 2 nested for loops, so it's going from 3, and then the inside for loop is going to run from 0 to 5, actually 0 to 4, and it's going to print the values of this thing. So running this code, it says that enter 15 integers, 5 per row. So just take a look at this line, enter 15 integers, 5 per row, and this running the we have calling the read function here. So we have declared a array, a 2-dimensional array of 3 and 3 comma 5. So we have 15 element array for 3 rows and 5 columns, and the important thing is the second or third dimension has to be passed correctly for the function to work. The first dimension is not needed because this is actually the name of the array is actually a pointer. So the function needs to know that how many elements each row has, or how many columns each row has. So this calling the read function, it says enter 15 integers, 5 per row, and it's going to say for this first iteration row number 0. So it's going to say row 0. So I'm going to put some numbers, 2, 3, 5, and let's say -9 and 4, and it says then it says row 1. So coming quickly here, so it says the next iteration will be to I0 to I1, then it will say row 1, and then it will be 1 0 1 1 1 2 1, and then it will take the 5 integers. So it's going to say like 2 6 7 -5 and 4, then it says row 2, then 2 9 8 9 and 2. Then after running this code for 3 rows 0 1 2, it populated the two-dimensional array, and then we called the print function. So print, we just pass a name of an array, and that's it. This is actually a pointer. So print function will go from the first loop, the outside loop will go from 0 to 2, and the inside loop for each column from 0 to 4, and it's going to print the values of aij, and then it prints the values of whatever we have stored in this. In the computer, actually this thing is all stored in the single line in a continuous memory space, but for us this is actually a two-dimensional array, and that's how we pass the array to a function. We never pass all the values. We pass the name of an array, which is actually an address in the memory, to the function, and the function works from there.